So welcome to Math 144 Club, the math class for students who are going to test soon and need some mixed review. Today, we are going to be looking at some algebra, the basic algebra that comes up on the GED. If you didn't know, consider yourself told, the GED is an algebra test for the most part. So you have got to be strong at these skills we're going to look at today. Some of them are harder than others. They're not all totally integral, but they're all definitely going to show up on your test. All right, we do have some GED students with us here today. We've got Amy, Andrea, Manal, and Stephen. They will be helping us through class today. So here we go. The amount of money that Jason, a plumber, makes an hour can be represented using the variable J. His manager, Mario, makes $1 less than twice as much per hour. His apprentice makes $8 an hour less than Jason does. Write an expression that represents the ratio of the apprentice's rate to the manager's rate. As usual, my question is, what are they asking us to do or to find?
The expression that represents the ratio of the apprentice's rate to the manager's rate.
Beautiful. Writing expressions, one of GED students' least favorite tasks. Writing in the language of algebra. But let's take a look at what they asked us to do. First of all, they asked us to write an expression that represents the ratio. Mathematically, when I tell you to write a ratio or to create a ratio, does anybody know what I'm asking you to do? What does that word even mean?
Is it kind of like a fraction?
Yeah, a ratio is a relationship between two numbers. And what kind of number has a relationship between two numbers within it? It's a fraction. And something important comes up when we're talking fractions or ratios. You should know that order matters. So you need to write your fraction in the order in which it's presented. So let's take a look at this. It says we want the ratio of the apprentice's rate. That's presented first. We're going to put that on the top of our fraction. 2, that's the signal for a fraction bar. The manager's rate. That's presented second, and so that's going to be on the bottom, the denominator of our fraction. So we said we wanted to start by putting the apprentice's rate at the top of the fraction. Guys, what do we know about the apprentice's rate?
Apprentice makes $8 an hour.
Keep reading. $8 an hour.
Less
exactly. Good thing the apprentice doesn't make $8 an hour, right? He'd be making less than minimum wage. But he's making $8 an hour less than Jason, and we had a problem. The problem is we don't know how much Jason makes. Look what it says about Jason. It says that Jason has this unknown variable J that he makes an hour. Dang it. So how can we say $8 less than Jason if Jason is J? If Jason is J and I want $8 less than that, well, I need to take $8 away from Jason's rate. Do recognize that it's not $8 minus Jason's rate. That's not $8 less than Jason. That's Jason less than $8. That's weird. Definitely, I can narrow it down right now to B or D because we see that apprentice's rate, that $8 less than Jason on the top of the fractions in the numerators on both B and D. So already, even not knowing too much about algebra, I can rule out C and A. Now let's examine the difference there, the differences in the bottom. So what's supposed to be on the bottom of our fraction? Well, we said it was going to be the apprentice's rate to the manager's rate. And what do we know about the manager's rate?
He makes $1 less than twice as much per hour.
Beautiful. Look at this. This might look like nonsense to you, but you know what it looks like to me? They're taking away $1. They're taking away $1 from what? Well, twice Jason's. 2 times Jason's amount is twice Jason's rate. I don't know why the manager gets paid so much when Jason's probably doing most of the work, y'all. D is a wrong answer because this is the rate of the apprentice to just Jason, but we didn't want the apprentice to Jason. We wanted the apprentice to Jason's manager. Beautiful. B is correct. We have a problem when we go to write in the language of algebra, and that is I am extremely fluent in algebra. I've been speaking algebra for like 28 years now, 10 hours a day. This is my language. And so sometimes I forget how challenging it is for a newbie because it is a foreign language. And because we have all these fluent people teaching it, it doesn't sound foreign to us. It seems very easy. The manager's rate to the apprentice's rate. This is one of the most common struggles for students in a GED classroom. Like, so foreign. They're like, it's like Greek. And I'm like, it's not Greek, it's the language of algebra. But yeah, it is a foreign language. Okay. Again, this is algebra. This is the topic of writing algebraic expressions. So a little more practice with this. I thought we could use it. A certain cell phone company charges 10 cents per text. Additionally, there is a $10 flat fee charged each month for the texting service. Which equation can be used to find the total cost C for sending T texts in a month? Now, I know you guys are like, Kate, you're old. We all have unlimited texting nowadays. But once upon a time, they charged us per text, you guys. What are we being asked to do or to find?
Asking which equation can be used to find the total cost.
Good. So once again, they're asking us to write in the language of algebra. This time, instead of writing an expression, we're writing an equation. Two equivalent expressions, two expressions that are equal to each other. We do have some letters, and Stephen pointed out that we're going to use C to stand for cost, and notice it's a capital C, and T to stand for text, little t, and we're trying to write an equation that could be used to find the total cost. Well, we know one way to say total cost. C is total cost. But remember, when you're writing an equation, you want two equivalent expressions. So what we need is another way to talk about the total cost. One way is just to call it C like they told us to, but the other way is to mathematically find the total cost. If you were looking for the total cost of this cell phone plan, what would get included?
That it's 10 cents per text.
Good. We have a repeated fee. We're getting charged this fee every time we send a text. What else do we know?
$10 flat fee charge.
What does a flat fee mean?
One time?
Bingo, a flat fee just happens once. That 10 cents per text is happening over and over again every time we text. But that flat fee, yes, it's per month, but it's just one time during that month. So we need an equation that says, to find the cost, charge me the 10 cents over and over again, and then charge me $10 once.
We use the formula.
It could definitely help us. So Manal knows that on the formula sheet, there is a formula that says
Total cost equal number of units multiple by price per unit.
You said the total cost was the number of units times the price per unit. That's that idea of getting a fee charged over and over and over again. So let's start with that. The number of units. Well, in this case, the units, the things that we're buying are texts. And how many texts are we sending? Yeah, I like it. Amy's going like this. I don't know, Kate. Exactly. That's the point. It's algebra. We don't know. They didn't tell us how many texts we're sending. They said we're sending T texts. Okay, so we're going to multiply T by something. What is it going to times by? It's going to times by the price per unit. Well, what's the price per unit? How much do we pay for each of those texts? 10 what? Be really careful. I got a lot of students who would say 10T, $10 per text. Don't you charge me $10 per text. I'm going to call you, yelling at you. How do we write 10 cents? If we're looking to have our answer in terms of cost in dollars, we're going to write our 10 cents kind of like that. Now you're going to notice they didn't put the 0 in their answers. They have these 0.01 T's, but I like this one. And, oh, look, that one, they messed up the letters on me. I don't like that one. So this one's already looking good. I got the 10 cents per text, and then look at that. And they add in the $10. Why do they add with the $10 instead of multiplying? Manal told me to find total cost, I have to multiply. How come the $10 got added in? Any thoughts?
It's a one-time?
It's a one-time fee. Exactly. When you're looking for a total, you multiply with repeated fees, 10 cents per text, and you add with one-time fees. We found the right answer without doing much work at all. A is the right answer. A lot of students who end up in a GED classroom have a symbolic processing problem. And their whole life, they've gone through algebra classes thinking they're stupid. And it has nothing to do with intelligence, and it has everything to do with the way your brain uses symbols. Some people use symbols more effectively than others. And so if you have a symbolic processing issue, you're going to look at this algebra and it's just going to keep looking like throw up on the page. It just keeps looking like nonsense and nonsense. And you feel dumb, like how come everybody's looking at this and it makes sense? But the good news is the symbolic processing issues are not life sentences. The more you practice, the more it becomes familiar and the less you struggle with it. So I would just encourage anybody who has this same feeling like, man, algebra is just so hard to understand, to keep at it. You really can get over that symbolic processing hump and start going, oh, that's what everybody's been seeing that I haven't been seeing, and start to read it like a language. So that is from the algebra unit. The topic here is writing equations. Evaluate the function below for x is equal to 3.1. And then we have this function. Before I begin and before I panic, what are they asking me to do or to find?
The x.
Actually, I already know the x. There it is.
Is this where you just plug in the
Oh.
value?
When you are given a value, yeah, Stephen, this is where we just plug in the value. And sometimes we call it plug and chug. Mathematically, that's what mathematicians joke about. Because, yeah, you're just plugging it in and crunching the numbers. So students look at this like, oh my God, this is such a hard algebra problem. Basically, as soon as we plug in the value, like Stephen said, it ain't an algebra problem anymore. Okay, so the first thing I need is for you guys not to get intimidated by this. Some students think it says f times x. It does not say f times x. You know, if mathematicians want to multiply two letters, they just shove them next to each other. That's f times x. Does anybody know what that says?
Is that the same thing as saying y equals?
It is. This is what we say f of x, and it means the exact same thing as y. And I think of this like how you guys have first names and last names. You know, I could be real informal with you and be like, hey, Amy, what's up? I'm just calling you Y. Or I could be like, hello, Mr. Bell. Now I'm talking by his formal last name. So f of x is kind of like a formal way of saying y. It says the function value when x is. So anytime you see that, you could just replace it with the letter y and then stop having such drama and trauma about the f of x notation. We are going to do what Stephen said. We're going to plug it in. Mathematically, when we talk about plugging it in, that is called substitution. So here we go. We're going to do our substitution step. I'll keep -2, and I replace that x with the known value. Now, nothing else is going to change. So I'm still going to have the square. I'm still going to have the plus. I'm still going to have the 5.7. But every time I see an x, I'm going to replace it with a 3.1. And I will change nothing else. That's the substitution step. Well, nice, because anytime we're doing algebra on the GED, you get a GED calculator. And take a look at this. See how on this right-hand side, there is not a single X left? There's not any letters left. It ain't algebra anymore. It's just a computation. And your GED calculator can do a long, ugly computation. So if you're a ninja who knows the order of operations yourself, that's great. But you can actually type this entire expression as is into your calculator. The TI does the order of operations for you. It's glorious. Even if you guys know how to simplify this by hand, can you please also practice it in your calculator so I can make sure you have the calc skills you need for the GED. So everybody pick up your calculator. If you have it, you try it too, and we'll compare our answers. So the negative button is down at the bottom of your screen. Don't use the minus key. Use the negative button down by the answer, the one in parentheses. So then -2 times 3.1, and then you can close parentheses. You can type it in exactly the way you see it on your screen. We have parentheses. And then we had a square button. To type square on the GED calculator, there's two ways, but the easiest way is just to type the x squared button. So there it is, x squared, and you can see it gives me a little floating 2. And then we'll type plus 5.7, and again, we're timesing, and I can do that with my parentheses, 3.1. plus the final 4.3. And you can type the entire expression into your GED calculator and it will do the order of operations for you. There it is, 2.75. The final answer here then is f of x, or y, same difference, is equal to 2.75. And all we had to know was that lovely skill of substitution, and the calculator could do all the computations for us. Technically, this is not an expression, this is a function, but it's the same skill. Whether you're evaluating expressions or equations and functions, it's the same basic skill. You plug, you chug. You put in the known value and you do the math, and if it's all straightforward simplifying, your calculator can do it for you. Next problem. All our directions say is simplify. That means when all our directions say simplify, that's not a very obvious, that's kind of generic math word. You're going to have to look at the signs and symbols to know what to do. So take a look at this. What am I doing here?
Is that adding like terms?
Definitely adding and subtracting like terms is going to come up here. Technically, what kind of a problem this is subtraction. Can you see that minus sign between these two big ugly things here? And what am I subtracting? These algebraic expressions. These type of expressions are known as polynomials. And Amy, you're absolutely right that the skills of adding and subtracting like terms are about to come up here, but they can't until we deal with the groupings. Notice that we have these parentheses here. Parentheses do things in math. They're not just there for no reason. A lot of students think every time they see them that they're multiplying, but here we're not multiplying. These parentheses are not shoved up against each other. We're subtracting, but we're subtracting one big ugly thing from another big ugly thing. And we have got to deal with that grouping. Any thoughts on that? Anybody know what happens when you have a subtract with an entire grouping?
You have to distribute.
Absolutely. Just like with multiplication, it's kind of like I'm multiplying this entire expression by -1. That negative is actually applying to every term in the grouping. Let's go ahead and deal with that. Obviously, if I subtract, this first term was a positive 8x squared. So if I subtract it, I'll end up with minus or a negative 8x squared. Nice. But it's not so obvious what will happen with the second term. The second term was already subtracting and I want to subtract it. Any thoughts? What happens when you subtract a negative?
You add.
It turns into addition. So it is going to flip its sign from a negative 11x to positive 11x. Wonderful. Now my next term was supposed to be adding to, but I want to subtract that whole thing. So it needs to change its sign as well. And I will end up with
-2.
Beautiful. Now, if there's nothing shoved up against these parentheses up front with this one, you can just drop those. So I will just drop those parentheses with no consequences. So now Amy is right. From here, now that I've gotten rid of those groupings, it is just a matter of adding and subtracting in algebra. We call that combining like terms. Remember that we can only add and subtract the same kinds of things. So let's examine the first term, 3x squared. Do you guys see any like terms? Yes, Manal, you're right. 3x squared and negative 8x squared are like, and they would combine to -5. And -5 what? Wait, if you're adding and subtracting x squareds, it'll still be x squareds. Now, some of us aren't that great at negative numbers. If this was on your GED, you would have the calculator, and you can do this in your calculator just without the x's. You do the 3 minus 8, you find out it's -5, and then you know algebraically if you were adding x squareds and x squareds, you still have x squareds. So let's continue to combine like terms. So we got our x squared terms together. Let's look at the next type of term we have. We have a plain old x term. Are there any other x terms?
+11x.
Absolutely. So again, if you were doing this in your GED calculator, you could do it without the x's, -5 plus 11. And you would see, like Manal did, that we get six x's. But I want to stop you from making a really common GED student error. A lot of students just shove that 6x right there. Careful, if you just shove that 6x right there like that, you are going to be turning something, a bunch of terms, things that are adding and subtracting, into factors, things that are multiplying. I need a plus or minus sign. So was it +6 or -6, Manal?
Positive.
So all right, plus 6x. Next term we have here is a constant term, a plain old number. Do you see any other constant terms?
-2.
Absolutely. Plain old numbers have always been able to add and subtract. We can go ahead and do that. And of course, 7 minus 2 is positive or +5. Now, I actually have to talk to you a little bit about this because it scares so many GED students to stop here. But this is as simplified as this is going to get. I got so many students now who want to try to mush together the 5, the 6, and the 5. You guys are so used to being good, obedient math students who obey all the signs. Y'all don't know when to stop. This is all we can do. You cannot add and subtract things that are not the same. We cannot add and subtract x squareds with x's with plain old 5s. We are done. Know when to stop. This is generally what separates my A students from my B students. My A students know they're done, they go on to the next problem. My B students spend the next 15 minutes trying to make up some kind of new magical math to squish these numbers together. It does not exist. The topic here is subtracting polynomials, and yeah, it puts together a lot of skills, including the skills of distributing and the skills of combining like terms. Find the product of 2x minus 3y and x plus 5y. Guys, what are they asking me to do or to find here?
Multiply.
Yes, find the product means, as Stephen pointed out, to multiply these two things. Be really careful, guys. This is a big, ugly expression. In this case, a binomial. It has two terms, 1, 2, and another big, ugly expression. And I want to make sure that the whole thing multiplies by the whole thing. Mathematically, if you want something complex, a grouping, to multiply with another group of numbers, you need to use parentheses. Just a times sign would not be adequate. So 2x minus 3y, that whole grouping in parentheses times x plus 5y. If you don't use parentheses, if you just use a regular times sign, you'll actually get a wrong answer.
So we can plug in this in the calculator?
Yes and no. You cannot put the x into the calculator. If you try to put x and y into your calculator will look for a programmed value of x and y and try to evaluate. So it'll look at if anybody ever said, oh, today I want x to be 1. So it's looking for a program value and it's crunching numbers. Your calculator cannot do algebra, it can only do arithmetic. So you have to know how to do the algebra. So you can put the numbers, we call them the coefficients in the calculator, but you have to know how to deal with the letters, the variables. So looking at these two things, does anyone know where to start? How to multiply these two things?
So you do 2x times x?
Absolutely. You start by passing out the first term to every term in the second grouping. So I'll do 2x times x. Careful now, a lot of students will tell me 2x times x is 2x, but that doesn't make sense. I already had 2x and now I want to multiply by another x. What will I get?
Square.
Exactly, 2x squared. Mathematicians use exponents to talk about repeated multiplication. That says a 2 and 2x is multiplying. So now what? Remember that just like when we're multiplying multi-digit numbers, you're not done until you completely pass the number out. Like when I'm multiplying 23 by 15, I multiply by the 5 by the 3 and the 5 by the 2. Same thing here. I need to multiply the 2x by the x, but I also need to multiply the 2x by the 5y. So what is 2x times 5y?
10xy.
Yes. Now that 2x has multiplied with every term in that parentheses, now I'm done with 2x. And now I can move on to passing out the negative 3y. Make sure when you multiply, you treat that like a negative 3y. So now I'm going to do negative 3y times x. Any thoughts? What is negative 3y times x?
Negative 3xy.
Beautiful. I love, Manal, that you didn't say yx. A really good rule of thumb is to write your variables in alphabetical order so that you don't miss like terms. And now, just like before, we are going to pass that guy out to everybody. So now that negative 3y will multiply with that positive 5y. Again, like we said, you could do the numbers in your calculator, Amy. You could do negative 3 times 5. Negative
15.
Good. But you would have to know what y times y is. Y times y is?
Y squared.
Gorgeous. Now I have finished multiplying. Technically I have the product. But as we know, we talked about it in fractions, it happens in algebra as well. You know, final math answers should be simplified, and there is more work I can do here. What else can I still do?
Positive 10xy minus 3xy.
Exactly. Manal sees that there's some adding and subtracting I can do. I can combine these like terms. XYs are like with other XYs. And so again, if you needed to put it in your calculator, we could just do the 10 minus 3, and we'd find out that's 7. 7 what? Well, if I'm adding and subtracting XYs, I have XYs. So 7 XYs. And of course, that was a positive 7, so it'll be plus 7XY. There's nothing like with my x squared term. There's nothing like with my y squared term. They just drop down to be in my final answer. And I am done. Do we see our answer here in this list? Yeah, looks like I have C. The biggest key, not just in algebra, whether you're in fractions, decimals, negatives, is knowing if you're in the land of adding, subtracting, or in the land of multiplying, dividing. because multiplying and dividing and adding, subtracting behave differently. You know, adding and subtracting is really strict. We can only add and subtract the same kinds of things. It doesn't matter if you're talking fractions, decimals, algebra. Multiplying and dividing, though, really loosey-goosey. Everybody multiplies with everybody else. There's always this passing out quality to multiplication and division. So super duper important to have that straight in your brain so you don't mix up the rules. This is the concept of multiplying binomials specifically, but in the crash course, I just have one page where we multiply all different kind of polynomials. Next one says factor 6m squared minus 13m minus 5. Just to let you know, for students who don't know what the word factor means, factor is basically the opposite of multiplying. It's pulling a number back out into a multiplication problem. Students usually don't think this way because we like to do the math, not undo the math. But it's basically like undoing multiplying. For example, if I asked you to factor 12, one way to factor 12, certainly not the only way, is to say, oh, 12 is the same as 6 times 2. I just factored 12. I pulled 12 apart into a multiplication problem. It is way easier to do the opposite, multiplying, than to work forwards here and factor. We all know how to multiply. So there's a reason why I had this problem follow the last one. We can use the same skills we used in the last one and work backwards. We can find out which one of these guys, look at them, they're just multiplication problems. Ugly ones, but multiplication problems. So which one of those guys would multiply out to equal up that term? And this is the cheat method I teach for factoring for the GED. I'm like, cheat, y'all. Let's just multiply out the answers. So let's do a guess and check method. Which one of these guys would you guys like to guess is correct? And then we can just start multiplying. Okay, let's try it. Let's see if we multiply this guy out. Are these the two factors that would give us this final expression? Okay, let's take a look. We're going to use the same skills we used before. We're going to start with the first term in the first parentheses, and we're going to pass it out. Multiplication passes out to every term in the grouping. Okay, so let's start with 2m times 3m. What is 2m times 3m?
6m squared.
Absolutely. 2 times 3 is 6, and m times m is m squared. And we just shove them real tight to say they're multiplying. Beautiful. And now 2m times positive 1.
2m.
Gorgeous. Next term I'm passing out is what?
-5.
Beautiful. Thank you for saying -5 and not just 5. I'm going to pass out that -5 and I'm going to multiply it by 3m. What would I get?
-15m.
Beautiful. And now I need to multiply?
-5 times 1.
Times positive 1. Beautiful. And that would give me?
-5.
So now I have this expression 6m squared plus 2m minus 15m minus 5. And it is not simplified yet. I can still combine these like terms. What would positive 2m minus 15m give me? And you can do it in your calculator if you need to. Positive 2 minus 15.
-13m.
-13. And I'm adding and subtracting m, so I will still have m's. Drop my 6m squared, drop my -5. What do you guys think of Manal's guess?
He was right.
It worked, yeah. I see a 6m squared term. It looks like Manal was working ahead of us as usual. A -13m, a -13m, and a -5, a -5. If you're to multiply any of the rest of these, I promise they would not give you the same thing. Okay, and so that's the idea here of factoring. Factoring is the opposite of multiplying, so we can always use that fact to work backwards and just do the multiplication. And that's how I cheat at factoring, y'all. Here's the deal. Here's the deal. Factoring is a lovely skill. If you guys were going to be in my college algebra class, I would totally teach you to factor because you have to know it. But it takes about 6 weeks to teach the 8 types of factoring for the typical GED students. I don't have 6 weeks in a GED class, so that's why I use the cheat method since we're doing multiple choice on the GED anyway. And the more you multiply these things out and notice the patterns, the easier it'll be to learn to work backwards. Just like the better you knew your times tables back in the day, the easier it was to learn to divide because you already knew your times tables and they're just opposites. So same thing here. The unit here is algebra and the topic is multiplying polynomials and factoring for the GED. Here we go. Solve the equation. What are they asking me to do or to find?
Yeah, you just have to solve it.
Can we just talk about what this word means? Because a lot of students use the word solve like it means simplify, and it doesn't. So if I talk about solving the equation, I'm talking about finding the value for the variable. Sometimes we say find x or find y. It means the same as solving the equation, right? Find the value for the variable that makes the two sides equal. So we have a relationship this time. We know there's a left-hand side that's supposed to be equal to a right-hand side. We can use that to solve the mystery, find out what y is actually equal to. What might I start with on an equation like this? Any thoughts?
Distribute.
Brilliant. What Stephen's noticing is that there's some simplifying I can do. The first general wisdom principle when solving equations, is to simplify the left and right hand side. If there's any straightforward math you know how to do, by all means, let's do it. And what Stephen noticed is that this 3 is shoved up against this parentheses there. And we know how to pass that 3 out. That's that same distributive property. Let's do it. 3 times y is 3y. 3 times -2 is -6. Now careful guys, when the parentheses stop, your distributing stops. That 3 is not going to touch that y. That y is outside of the grouping, so it's outside of that act of multiplication. When you're simplifying, you only work one side at a time. So let's look at the right-hand side as if it is its own expression. It is. Is there any simplifying or straightforward math you know how to do over there?
You can do 2y plus 8. 2 times 4, 8.
Yes, I can do the distribution over there, Andrea. Nice job. So 2 times y is 2y, and 2 times +4 is +8. The left side is not simplified yet. There is more work to do over there. We do have like terms to combine, so absolutely, let's get them combined before we start doing anything else. So, Stephen, what terms did you see on the left-hand side that were like?
The 3y and the y, you could just add them.
Absolutely. We have always been able since the beginning of math to add up the same kinds of things. So guys, if I have 3y and then I add in another y, what am I going to get?
4y.
4y. Thank you for not telling me 3y squared. I'm not multiplying, I'm adding. I had 3 y's, and then I came and brought another y. That's a total of 4 y's. Okay, it's just like if you have 3 apples and you bring in another apple, you're gonna have 4 apples. Okay, wonderful. So I get 4y and I just drop the -6. Now examine the right-hand side for me. Do you see any more simplifying I can do over there?
No.
No, the only thing to do is addition, and we can only add and subtract like terms. Y's and plain old numbers are not like, and so I just drop it. Gorgeous. I have simplified my left-hand side and my right-hand side. What shall I do now?
Nothing.
Nothing. Amy's like, you give up, you cry. This is the point where you cry in algebra. That's what I always I'll take that out of the video, girl. Maybe I won't though, because I think a lot of people just cry right now. We just won't say that Amy said it. But yeah, a lot of students here are like, now's when I cry. Okay, so instead of crying, what could we do, you guys? Any thoughts?
Move your y term.
Bingo, Stephen. We got a Y.
This feels so good. I practiced this a lot. This was like a one of my weak points at one time, but I practiced it so good. I'm so good at this.
Yes, I love to hear that. Stephen says at one point he was weak at this, you guys, but he practiced and now he's got it down to a science. We cannot have a Y on the left-hand side and the right-hand side. He's right. We got to get those Y terms to the same side. Okay. So any thoughts about which one you want to move, Stephen?
I prefer mine to be on the left side, but I know it doesn't matter.
Beautiful.
I learned from you, so.
Yeah, I know. Sounds like you're talking about, I'm like, Stephen's got me memorized. Okay, sweet. So I like it on the left-hand side. A lot of students do, so let's do that. Let's take this 2y over here that's on the right side, move him over to the left side. How could I move him?
You just do the inverse and subtract. And move.
Beautiful. Thank you for subtracting and not dividing. When we're moving the entire term, we're always adding or subtracting, as Stephen clearly knows. Now we can do whatever we want as long as we do it to both sides. Make sure you jump across your equal sign. You do the same thing over there. And let's see what my new equation will be. After I do that, what will my new equation be?
2y minus 6.
Beautiful. If I have 4y and I take away 2y, I have 2y left. And that -6 was not touched. It's still there. That's on the left-hand side. And on the right-hand side, well, 2y minus 2y zeroes out. And the only thing I have over there is
Plus 8.
+8. Yes. Okay, sweet. Now what?
You need to isolate, do the opposite of -6, make it a +6, and move it to Where the 8 is on the other side of the 8.
Beautiful. Let me finish writing down what Stephen said. Stephen says, next I need to isolate the variable. I need to work to get the letter alone. And Stephen and Manal are right that the first sucker I should move is definitely the 6, because when you isolate the variable, when you start solving, you work the order of operations backwards. We're going to move anything adding or subtracting first. So yes, I will use the inverse of subtract 6. I will add 6 to both sides. Nice job. What will my new equation be?
2y equal 14.
2y. The negative 6 and the positive 6 canceled out. Only thing left on the left is 2y, and that's equal to 14. And thank you guys for being super patient as I talk through it every time, but I want all my students to have my voice in their heads, kind of like Stephen does when they go to tests, so they can talk to themselves through their problems. Okay, so now I have 2y is equal to 14. Am I done? I'm so done.
No.
Not done. The letter's not alone. What can I do to isolate this variable? Get it alone.
Do minus the 14.
Do you see how the 14's on the other side as the y?
Yes.
It's already out of my way. The only numbers that I have to get rid of are the numbers hanging out with y. So if you struggle with that, putting a line through your equal sign can help you see the difference between the left-hand side and the right-hand side. And you can see that the reason y is not alone is because of that 2. I got to get rid of that 2. Every move I make right now is calculated to move things away from y, other side of the equal sign. So somebody tell me, how can I get rid of that 2?
2 on y means it's multiplying, so you have to do the opposite with the line.
Bingo. 2 squished against y means they're multiplying. I'll do the opposite. I'll divide. I can do whatever I want as long as I do it to both sides of an equation. And now my new equation will be?
7.
Well, 7's on one side. Yes.
Y.
Yeah, y is equivalent or equal to 7. It's not solved until I know what y is equal to, what y would have to be. Well, y would have to be 7 to make this original equation true. And y is isolated. Any questions about that?
Just the concern of having enough time when I'm taking the test to do this. That's like what I'm terrified.
Here's one of the things. This skill of solving multi-step equations, that's what this is, solving multi-step equations, always reminds me of driving a car. Okay, who remembers when you were first learning to drive a car? You remember when you got in, you had to run through the checklist in your mind? Okay, to the seatbelt, I need this, oh, my mirror, and the other mirror, and now I got to put it in reverse. And remember how much thinking you had to do, and you had to walk yourself through every step? Girl, what happens when you get in the car now? You know you're not even thinking about it. You're putting on mascara. You're eating your breakfast. You're backing up. You're talking on the cell phone. You're doing like 87 things at once. You don't think about it one time. Solving multi-step equations is just like that, and Stephen is our proof. You can start at the point where it is so hard and you have to think so hard about every step and get to the point where it's like second nature, I don't even think about it anymore. Now I do this and now I do that. And so practice, practice, practice.
I struggle with this at the beginning, but now if you just know what to do, it just clicks.
And so it's so important to get past that stage where it's me talking you through it. Then you get to the stage where you talk to yourself through it. And then you get to the stage where you don't have to talk no more. Is autopilot. You got like a muscle memory. It's a brain memory, but a muscle memory for it.
Then I can't wait to get there.
Okay, well, let's talk about how to get there. Okay. You get there by hitting up the algebra unit in the crash course and going to the solving multi-step equations page. I got 3 different practices for you: simple, experience, advanced. You can keep on trying this. And I also have a ton of videos because students struggle with this so much. There's got to be like 10 or 12 practice videos down there with a bunch of these problems. So let's look at the next one. Given the equation below, which of the following could be a first step in solving the equation? Now, I want to warn you, watch the language very carefully. And this is why speaking my language as Stephen's learning to do can be very helpful here. Because I have a lot of multiple choice answers that I am trying to trick you. I won't even lie. I'm trying to be like the GED and trick you if I can, okay? This is a multiple choice with kind of some language here, so let's read through and see what we can do. Now, we are looking for which of the following could be a first step in solving the equation. So what would I do first if solving? Now, the problem is, yeah, Stephen learned my wisdom principles, But not all people solve equations the same way. My students tend to, because I have those 3 wisdom principles, but sometimes there's more than one right thing to do, okay? More than one of these answers might seem tempting. Let's go ahead and take a look. A, distribute the 2 to every term on the left-hand side. What do you guys think of that statement? No or maybe? Don't tell me yes, just tell me no or maybe.
Maybe.
Okay, so we have a maybe. What do you like about that, Andrea?
I said 2 times 4, 8.
Oh, yeah. She's like, yeah, there's some I could start by distributing here.
8x.
Okay, so maybe. Okay, so let's look at the next one. B, combine like terms on the right-hand side. No or maybe?
I would say yes.
Oh, Stephen likes that one. Yeah, there's a right-hand side, and the only thing over there to do is add and subtract, also known as combining like terms. That looks like a decent answer as well. Uh-oh, 2 decent answers. Let's keep going and see if we can rule anything out. C, add 3 to both sides of the equation.
I would say no.
No, Amy's right. You cannot, or I would not, I shouldn't say you cannot. I would not try, as some students do, to try to add the 3 to both sides of the equation here. Problem is not so much because it breaks Kate's principles. The problem is this 3 is trapped inside of a grouping right now. You can't deal with the adding and subtracting until you deal with the fact that it's in a grouping. That would probably be a foolish move. I'm going to go ahead and rule that guy out. Even though I couldn't do it, it wouldn't probably be a wise thing to do. D, divide both sides of the equation by 2.
No.
Yeah, I wouldn't start with that either. It's not that you couldn't do it, it's that a lot of students try to do it right here. They don't remember the fact that division passes out to everybody. You're gonna get some funky things if you divide both sides by 2. Probably not a great first step here. Okay, so that brings us down to 2 answers. Distribute the 2 to every term on the left-hand side and combine like terms on the right-hand side. One of these, I'm trying to trick you, and one of these is a better answer. Any thoughts on that, you guys?
I was thinking that this 2 because you start with a parentheses, right?
Well, the left-hand side and the right-hand side are totally separate expressions, Amy. So it doesn't matter which one you start with. So the first thing on the left is definitely distribution. The first thing on the right is definitely combining like terms. It doesn't really matter if you start with the left or the right since they're totally separate. So I don't know if that's enough reasoning to choose one.
Okay.
But there is something that would totally eliminate one of these answers.
We have to remove the a because you can't multiply 2 with everything, only with the 4x minus 3, but without the minus 8.
There you go. I tried to trick you with language. I'm a brat. Manal caught it. Yeah, the 2 would get distributed. You're right. That could be a first step, Amy. But look at my language. I said distribute the 2 to every term on the left-hand side. Manal's right. That 2 would get passed out to the 4x and the -3, but see that parentheses ending? It would not get passed out to this term, the -8. It is outside of the grouping. It is not part of the multiplication process. I was trying to trick you. I'm a snot. B is a better answer, even though it's the right-hand side, would not instinctively be our first step. But because of the language there, that's a better answer.
That was a good one because I could see where you could get the -8.
Yeah. And it's a typical student error. So they're trying to make sure that you don't make the typical student error.
Lucky for you, Kate, I'm the typical student.
You know, you guys, the thing is when you're first learning a new concept, you make mistakes. I'm now just relating it to learning to drive again. I remember how many times I changed lanes without looking over my shoulder and almost killed someone. My mother would be like, ah, there's someone in your blind spot. Again. How many times did I almost kill someone forgetting that thing? So this is going to happen when you're a new algebra student. You're going to almost kill algebra forgetting crap. Okay, we've got to get it to the point where it's second nature so we don't even think about looking over our shoulder or stopping our distribution. But it takes a while. It takes practice. So this is the topic of algebra. Again, it's solving multi-step equations. This is definitely a more challenging example, but very GED style. This is straight from their worksheet, by the way. The GED Testing Center sent adult education teachers, a list of commonly missed GED problems. This was from a version of the test. They released everybody, all the GED students taking the test are missing this one. And so I took those problems that they released and changed the numbers, but I wanted to give you guys a chance to see it so you're not those students missing this. So here's another one from the commonly missed GED section. A student solved the equation below as follows. In which step did the student make an error? Okay, what are they asking me to do or to find?
Find where the student had a misstep in solving the equation.
Exactly. We are looking for the wrong line, a line that doesn't make sense, that should not have happened. We are looking for an error. Now, I got to tell you, I am a GED teacher and a math teacher who does math all day long, and I still struggle to just stare at students' work and find the right or wrong answer with all the symbols. It is going to be much easier if you work the problem too. So make sure you have your scratch paper out. Please do not use the student method of stare real hard at it. That is not sufficient. So I'm just going to give myself some space. I'm going to write this sucker out and think about what I would do, and then I'll compare that to what they did. Where might you start on a problem like this?
Do the distributive property.
Absolutely. Once again, Stephen sees the distributive property. Now, I say the distributive property on the right-hand side, super easy to see. But on the left-hand side, not everybody sees it. Do you guys see the distribution on the left-hand side? Now that negative, whether you think of it as a -1 or a minus sign, is shoved up against these parentheses. See that? That's like that first one we did way at the beginning, Andrea, with that subtraction needs to pass out to everything in that parentheses. So that is where I should start. So let's go ahead and do that. So on the left-hand side, my 2x is outside of the parentheses. It won't get involved. But if I pass out that minus to the 4x, I will get?
Minus 4x.
Beautiful. And if I pass out that minus or negative sign to the -3, I'll have minus -3 or +3, right? The opposite of subtracting 3 is adding 3. Now let's simplify the right-hand side. What will I get?
5x minus 5.
Beautiful. And 5 times -1 is, yes, -5 or -5. Gorgeous. And then as we just talked about in the last problem, we stop at the parentheses, so the -6 will remain untouched. Compare that now to their step 1 over here. What do you think? Did they make an error there, or are they okay?
Did it right.
Sweet. Now, any thoughts? What should I do next?
Combine.
Beautiful. There's still some more simplifying I can do. What Stephen's seeing is that there are some like terms on the left-hand side that can combine. And I hope you're also seeing that on the right-hand side, there are some like terms that can combine. Beautiful. Let's continue that simplification and combine our like terms. On the left-hand side, 2x minus 4x would give me?
-2x.
Beautiful. And my 3 is a constant term. There are no other constant terms. It just drops. On the right-hand side,
5x.
and then my constant term will be
-11.
11. Beautiful. Now, Manal, when you say yes, good, are you comparing it to their step? Looks like they did their work well?
Yes.
Beautiful.
3, there's a problem in step 3.
This one, you think is the problem?
Yes, yes.
Okay, let's take a look at what they did here. It looks like Stephen, they went to get their letters to the left. Notice how I'm checking out what they did, because we can move letters any way we want. So super important. So let's try like they did to move our letters to the left. I've got to move this 5x term. How could I move this 5x term?
It will become negative.
I'll subtract it away. I can do whatever I want as long as I do it to both sides. And let's see what I would get here.
Here's the problem.
Yes, -2x minus 5x. If I am already subtracting 2x and then I subtract another 5x, now I'm really in trouble. I've subtracted 7x's. Oh, it looks like they moved the 3 as well. Ooh, we don't usually do 2 steps at once, but this student did. I'm going to just move the 3 as well, since they don't have a 3 over there. On this side, that would zero out, and on this side, I would get -14. And yeah, I agree with Manal. This says 7x is equal to -14. I have -7x is equal to -14. They have a sign error.
And also the answer.
Yes, but you have to find the step where they made the error. I mean, if their step 3 was right, their step 4 would be right too. So where they made the error, Manal, was in step 3. This is the hardest example of solving a linear equation that would come up on the GED, because now we have the fact that not only are we solving a multi-step equation, but there's more than one way to do it and get to the right place. So it's not just like, did they do it the way you would? It's, did they do something true or something false? I hope you don't get one this challenging on the GED. This was on, like I said, it was on the commonly missed problems from the GED. It doesn't mean that every multi-step equation is going to be in this format. They could just give you a straightforward one to solve, like the one we did before. I'll tell you one thing, you'll definitely have a multi-step equation. Here's 3 different examples we just looked at of how your multi-step equation could look. They could just give you a straightforward one where you do it yourself, but they could also give you an application of this, like this one. This thing says solve for X, and how gross. Look, Amy looks like she wants to puke. Any thoughts?
We solve, right?
Yeah, it's just like an equation. Inequalities, and those are, they look like equations, but instead of having equal signs, they have these inequality symbols here. Inequalities are solved just like equations. All the skills you use for equations, you use with inequalities as well. There's just one additional thing you need to know. So we're not abandoning all our old rules. All our old rules, all the things we've been doing on the last 3 problems are still going to apply, but we have an additional rule. So one more thing to know, and that is that if you multiply or divide by a negative, it flips the relationship between the 2 sides. So you will need to flip the inequality symbol. Imagine this was an equal sign. What would you do first?
We multiply 5/4.
Thank you. So many students are so intimidated by fractions that they just see one and freeze up. So if that's you, don't feel bad. But what Manal's noticing is that 5/4 is shoved up against that parentheses. As gross as it is multiplying. And you can use your GED calculator if you need to, but we need to do -5/4 times 8x. What is -5/4 times 8x? Type it into your calculator by typing the negative button and then the n/d button to get your fraction. You type in the 5 here and the 4 there and multiply it by 8. And you should get -10. And -10 what? -10 x's. Your calculator can handle the fractions for you, but you have to be able to do the algebra. But I'm not done. That -5/4 needs to keep multiplying. We passed that out. So now we're going to do -5/4 times -32. What is -5/4 times -32?
Plus 40.
Beautiful. Manal, did you do that by hand or in your calculator?
No, by hand.
Yeah, I like it by hand too, because we can just reduce, dividing them both by 4, and I get 8, and -5 times -8 is +40. But even if you type in your calculator, you should get +40. Make sure you write the plus with the 40. Cool, I simplified the left-hand side, just like on the last 3 problems. Then how about the right-hand side? Do you guys see any simplifying I can do over there?
It'd be 7 plus 1.
Brilliant. Plain old numbers are light. 7 plus 1 will give me 8. And of course I have the -2x that I haven't touched. Any more simplifying I can do?
You should move your x term from the right to the left.
Stephen's right. I need to get my x terms together. And Stephen, this is when I would agree with you about the left-hand side. When you're doing an inequality, we almost always put the letter on the left. So let's just get that letter on over. So yep, I want to move this -2x term from the right-hand side over to the left-hand side. How could I do that?
Do your inverse. You add the 2x.
Beautiful. And I can do whatever I want as long as I keep my balance. I do it to both sides of, in this case, the inequality. Cool. What will my new inequality be, you guys?
-8x.
-10x plus 2x gives me -8x or -8x. And to that, I still have that 40 that I haven't dealt with yet. I've done nothing to flip my sign. It's going to stay. Careful, a lot of students just drop it because they don't like it. Keep it. Make sure it's still there. And on this side, the subtracting 2x and the adding 2x cancel out, so all I'm left with is 8. Gorgeous. What shall I do now?
You isolate your variable, subtract the 40.
Beautiful. I'm going to isolate that variable I'm solving now. I'm working that order of operations backwards, moving anything adding or subtracting. Lovely. That cancels out. And I get -8x.
-32.
Yes, -32 on the right-hand side. But how about my inequality symbol?
It will be the same.
It'll be the same. Good. It does not move when you subtract. I'm going to say that again. It does not move when you subtract. The only time that sucker flips is if you multiply or divide by a negative. Cool. What shall I do now?
Minus 32 over minus 8.
Ah, over. Yes, I'm going to divide. Beautiful. I'm going to divide both sides of my inequality by -8. Right now, that -8 and that x are shoved up together. They are multiplying. The opposite of multiplying is dividing. Careful not to add 8, another very common student error. It would be different if they had a symbol between them. Now I could add 8, but they're shoved together. They're multiplying. The opposite of multiply is divide. Let's see what happens. Multiplying by -8 and dividing by -8 are opposites. They cancel. X is here. -32 divided by -8, of course, is +4. But how about my symbol? Should it stay the same or should it change?
Is it going to change?
It is going to change. Stephen, how did you know my inequality sign should flip?
Because you're dividing by a negative.
Beautiful. I divided both sides by a negative. I flipped the relationship. I must flip the inequality symbol. It will go from being a greater than or equal to a less than or equal to. My solution is x is anything that is less than or equal to 4. So x could be 4, 3, 2, 1, anything less than or equal to 4 in order to make this inequality true. Most of you guys go and do all the hard work right and forget to flip the sign and tell me A is the right answer. And the GED knows that. It'll be there. It will be in your solutions.
Yeah, that's going to be something I need to definitely work on to remember the flipping.
And it's tricky, Amy, because we don't always end up flipping it. And we only flip it if we multiply or divide by a negative. So you really have to know when you're doing what you're doing. But a lot of the examples I see on the GED include that because they know that students forget it.
Yeah.
Stephen, your hard work has really paid off. You were not intimidated by these things, and I'm giving you ugly. These are ugly. I'm impressed, sir. Unit is algebra. Topic is solving inequalities. I don't know if anybody's ever seen Hitchhiker's Guide to the Galaxy or read the book, but on the cover of the Hitchhiker's Guide to the Galaxy, it says, don't panic. So that is my message to you right now. Don't panic. Here we go. We can do this next one. Bernardo's restaurant is hiring servers. The owner, Bernardo, wants to guarantee that servers can earn between 100 and 200 a night in tips after tipping out the bussers. The inequality below can be used to find S, the daily sales the restaurant needs to make on a night when 6 servers are scheduled. Use the inequality to find S, the range of sales the restaurant needs to make each day. A lot of students who look at this and go, oh my God, word problem combined with algebra, I'm gonna lose my mind. And I'm over here like, yes, it's not a word problem at all. They gave me the inequality. It's just algebra. But what did they tell me to do? What are my directions saying based on all this nonsense here?
Use the inequality to find S.
Good. They're asking me to find S, or as we also say, solve for S. They're asking me to do algebra, the same crap I was just doing. So I'm going to copy out my inequality so I have room to work. But this kind of inequality freaks a lot of students out. So I just want to point out to you that this is what's called a compound inequality. It doesn't have 2 expressions. It has 1, 2, 3 expressions that are related to each other. But guys, all the rules of solving still apply. I can still simplify if any of those expressions will simplify. I can still do whatever I want as long as I do it this time to all 3 expressions. I got to keep my balance. So I'll just, if I want to do a change, sure, I could do a change. I just got to do it to everybody. And then my goal is still the same. My goal is to get the letter by itself. Why don't we start with what we just said, simplifying? Is there any simplifying I can do over there? Well, there's nothing to do. It's just a number. Same thing over here. Nothing to do. It's just a number. So how about right there? Is there any simplifying, any straightforward math that you know how to do or would want to do here?
150 over 6. We divide the 0.15.
I suppose you could. Manal, you totally could if you wanted to. But I don't want to. You know why I don't want to? Because I don't know what 0.15 divided by 6 is, and it sounds kind of gross. But Manal, you would get the same answer if you did. But I also know that I can move forwards or I can move backwards. Manal says I would divide by 6. And I say, you know, you could, but it looks like ugly math. I would rather get rid of the divide by 6. I would rather do the opposite. Guys, what's the opposite of dividing by 6?
Multiply.
Bingo. That's what I want to do. I want to multiply by 6. Amy says, can you do that? Girl, I can do whatever I want as long as I do it to all the expressions. I'm going to multiply this by 6, and I'm going to multiply that by 6. I can do whatever I want as long as I keep my balance. And then I don't have to do the nasty division, okay, Manal? But you would get the same answer if you did. Let's make it happen. Let's look at the left-hand side. All the way of that expression on the left. What is 6 times 100?
600.
Yes, ma'am. Now, look at the middle. Everybody goes, oh my God, I don't know what to do. That's so gross. I'm like, you guys, multiplying by 6 and dividing by 6 are opposite. You don't have to do jack. It just canceled. What's left in the middle there is just that expression without the 2 6s. So we have 0.15s minus 150. The multiplying by 6 and the dividing by 6 canceled. 200 times 6 is 1,200. Okay, so you can do the division or you can get rid of the division. We can simplify or solve in the land of algebra. We have choices here. Any thoughts now? Again, remember that my goal is to get S alone.
We moved the minus 150.
Absolutely. Take a look at this expression. S is not alone because we have 150 hanging out and we have 0.15 hanging out. I got to get rid of those two numbers. And Manal wants to get rid of 150. And I agree. We move terms, things that are adding and subtracting first. And so I am going to add that 150. Now, again, we can do whatever we want as long as we do it to all the expressions. So I'm going to add it over here to the 600 and I'm going to add it over here to the 1200. Same skills. They're just getting more complex, but it's the same thing we've been doing. Okay, so what will my new inequality be?
750.
And I've done nothing to flip my inequality symbol. And then in the middle, subtracting 150 and adding 150 are opposites. They cancel. So all I have left is that 0.15s. And I've done nothing to flip my inequality symbols. And then on the right-hand side, I will have
1,350.
So then how could I continue this process of working to get S alone? What number do I need to get rid of now?
0.1.
Amen, Amy. That's exactly right. How do I get rid of that 0.15?
Dividing.
Dividing. It is multiplying. I will do the opposite. We use inverses to move things. Now we can do whatever we want as long as we do it to everybody. And pick up your calculator. I am not even trying to do that by hand. I don't know what kind of time you guys think I have. What is 750 divided by 1500ths?
5,000.
Good. Now this time I did not multiply or divide by a negative. So I've done nothing to flip my signs. So they will stay. Now multiplying and dividing by that number cancels. So S is alone just like I wanted. And on the right hand side, if I simplify that expression, I'll get
9,000.
So what do we need to sell during the day? Well, we need to sell between $5,000 and $9,000 if we're going to keep our promise to our servers.
That hurt.
It's gross. It's gross. It's, you know what it is? It wasn't that bad of a problem. The math wasn't that hard, but I feel like it's intimidation tactics. A lot of what the GED does is just so visually intimidating to students. We don't even know where to start. We just want to puke and give up. So we saw that Manal would have started a different way than I would have, and we still got the right answer. So you don't have to know everything to do, just the next thing. What's one thing? What's something I could do? All right, here we go. The hardest thing on the whole GED. We can do it. What are the solutions to the equation x squared minus 4x equals 21? Quadratic. It's so nice if you're the blessed human who can just look at this and go, hey, that's a quadratic equation. Help the rest of us know how you knew that. What about this particular equation told you it's not like the other ones we've seen? This is a different scenario.
It's squared.
Thank you, Stephen. When your variable is squared, so it could be an x squared or y squared, whatever, but it has that little 2 on it. When your letter has that little 2 on it, this is what we call a quadratic equation. Now, quadratic equations take more skills than linear equations, the kinds we've been doing. So those 3 wisdom principles, you know, where we've been simplifying, getting the letters together and then isolating, you could play with those all day long and it wouldn't be enough. You need bigger muscles for a quadratic. You need more skills. Now, you go to your college math classes, they're going to teach you 3 different ways to solve quadratics, you know, at least. And my husband showed me a new way the other day as well. So there's lots of ways to solve these, okay? But again, I only have so much time to give you. And so I'm going to teach you the way that always works. It's kind of the long, slow way up the hill, but it always works, okay? So the way that always works is the quadratic formula. Hit up your formula sheet. So I am just hitting up Google, okay, you guys? And no, I'm not Googling the GED math crash course, but you probably should. I'm going to Google the GED formula sheet. And the very first thing that comes up for me is from GED.com. That's where I want it from, guys. Don't trust anybody besides the testing service to give you what you want. Here's the GED formula sheet. And you're going to see right down here towards the bottom, There is the quadratic formula. And it is the grossest looking formula we have, but it is still just a formula, which means we can use our formula skills. We need x is equal to negative b, and we read that sign as plus or minus. That's telling me there's two answers. There's one answer when you add and one answer when you subtract. The square root of, and notice it's a real long square root symbol, b squared minus 4ac all over, that fraction bar stretches all the way to a. You don't have to have this memorized for the GED since it's on your formula sheet. All I have to do is plug in A, B, and C, and then I'll know what X is. But crap, what are A, B, and C? A, B, and C are the coefficients when the quadratic equation is in its standard form. And so in order to start this, take a look at my equation. Right now, my equation says x squared minus 4x is equal to 21. I often joke that a quadratic equation is like a party. Instead of trying to work to get x alone this time, you work to get everybody to the same side. You want this whole thing equal to 0. So instead of working to get things away from x, I'm going to work to get everything towards x. I'm going to take that 21 over and bring it to x's side. Now, that being said, let's see what we have. Of course, 21 minus 21 is 0. Now, take a look. I have an x squared term, I have an x term, and I have a plain old number term. Those are not going to combine. I'm just going to write them down next to each other. X squared minus 4x minus 21. Now what you're going to see is that I have these three numbers on the left-hand side, and the whole thing is equal to 0. That's what I want. If it's like that, then I can see my A, my B, and my C. My A is my coefficient with my x squared term, the number that's with x squared. Now, a lot of students say to me, Kate, there's no number there. But you should know what the invisible coefficient is. If that's just an x squared, that's how many x squareds? Well, that's 1 x squared. So my A in this case is 1. And now my next term is negative 4x. So B is the coefficient with x, the number out front of the x term. So my B here is negative 4. And then C is my constant term. It's my plain old number term. And I can see my constant term is negative 21. So I just got my A, my B, and my C. Remember I told you this is the long, slow way up the mountain? This is not the fastest way to solve this problem, but this method always works on every quadratic equation. So this is our way to only memorize one method instead of many. Here we go, let's plug in. So the first thing I need is the opposite or negative of B. Well, B is negative 4. So the opposite or negative of B would be
4.
Exactly. And that's got to be plus or minus the square root of b squared. Now careful, when you plug negatives into squares, you need to use parentheses. So that's negative 4 with parentheses squared minus 4. And then I'm supposed to times it by a. Well, what is my a?
1.
Good. And then times c, and my c is?
Negative 21.
Negative 21. And the whole thing is over 2 times my a, which is 1. And yes, this is the ugliest example of a formula that we've seen, but it's the same stinking skill of substitution. Yes, it's a challenging substitution problem, but all we did was substitute. And now guess what? You can plug that entire thing into your TI, okay? Now, you can simplify it by hand by all means. It's a very challenging order of operation problems, or you can use your TI. So let me show you how to use your TI since we're lazy and we don't have a lot of time. Ready? So to do this in your GED calculator, let's first make sure that we're in the right mode. So you're going to go ahead and you're going to hit the mode button. You can see right now that I am in math print mode. That's what I want to be in for these long, complicated expressions. But if you're not in math print mode, the way to do that is just to arrow down to the word math print. Make sure that we're blinking black on math print, press enter to select that, and then clear to get out of that screen. Now, to type this sucker in, again, we want our fraction first, so hit the N over D button. Should be blinking like that horizontal on your screen if you're in the right mode. And then we were typing 4, and we were gonna start with the plus. And now I want the square root. See how the square root's there in green? Anytime you want something green, you must hit the second button right before you hit that x squared key in this case to get the square root. Open up your parentheses. If you don't have a parentheses, it will give you a wrong answer. And then you get your negative 4. Close the parentheses before you hit x squared to square it. Notice that we use the negative key and not the minus key when we're signifying that we want to multiply or divide with a negative number or raise it to a power. Now that's supposed to be minus. When it's between numbers, you must use a minus key. 4 times, use the parentheses, 1 and our C was negative 21. Now I'm going to arrow down, and yeah, we arrow out there, and we can do the 2 times 1 down at the bottom of the fraction. So now I have everything in there, and I press enter, and we should get the answer 7. Takes a little bit to get used to this calculator, doesn't it? There is a page on the crash course that's just playing with the calculator. I highly recommend you try it. In order to get the second answer, remember I said you don't have to retype the whole thing. You can just arrow up to this expression. See how it's black right now, Manal? Press enter to select, and it's going to appear on my screen again. And then I can just use my arrow key. I'm just arrowing over the plus to turn it into a minus. So the second answer comes when you turn that plus sign into a minus sign, and then I press enter to select. And look at that, -3. Nice shortcut if you know how to use it. Or you can just type the whole thing again, I suppose. So correct answers here, what were they, 7 and -3? For those of you guys who do know how to factor, use the factoring method for quadratics, that would be the easier way to go here, FYI. With that being said though, remember I said the quadratic equation always works? Here is another equation, and guess what? You need the quadratic formula. Take a look. It says solve the equation for a, and I see 2a squared plus 5a plus 2 equals 10. Once again, you're going to notice, like Manal noticed last time, the square on there. This is a quadratic. But this was not the only clue. I was looking at a quadratic equation, guys. Look at these answers. Aren't they gross? Because of that ugly, gross formula, sometimes we get some pretty gross answers on a quadratic equation, okay? They're not always pretty like on the last one. But with that formula, we can always find them. So that being said, though, I have a problem. This sucker's not in the right form. Do you remember what I had to do with this equation before I could use the formula?
You have to zero it.
I have to make it equal to 0. It is not equal to 0. Quadratic equation's like a party. We got to get everybody to the same side. I'm going to take that 10 away. I can do whatever I want as long as I do it to both sides. And let's see what my new equation will be this time. Well, I don't have any other a squared terms, so that'll be the same. I don't have any other a terms, so that'll be the same. But I can combine these like terms. 2 minus 10 is?
-8.
-8. And now it's equal to 0. And now I can see my A, my B, and my C. So let's bust out that quadratic formula. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. And again, you don't have to have this memorized. You just have to look at your formula sheet for the GED. Now let's do our ugly substitution step. It might be gross, but it is just substitution. So first I need the opposite of b. What is b?
5.
Exactly, it's 5, so the opposite of it is -5. And that's going to be adding or subtracting with the square root of b squared. What is b?
5.
Good, 5. This time it's positive. -4 times a times c. What is my a and what is my c?
2 minus 8.
Good. 2 is my a and my c is -8. Beautiful. And the whole thing is supposed to be over 2 times a. And what did you say my a was?
2.
2. Now, like I said, you can plug this entire thing into your calculator. So if I wanted to type this into the calculator, again, I'm already in math print mode, so I'm good to go on the modes, but I make sure I hit the N over D button first. And then I have -5, and we'll start with our plus key. And to get the square root, it's in green, so you need to hit that green second button, and then square root. And then we are squaring 5. And it actually doesn't matter if you put it in parentheses when it's a positive number, but it's just a good habit. And then we're going to square that. -4 times my a,
2.
2, and times my c, -8. And I use the negative key, not the minus key when I'm in the parentheses. And now I'll arrow out of my square root and down to the bottom of my fraction and go 2 times my a. And you guys told me my a was also 2. And press enter. And what?
Error.
It shouldn't give me an error. I did something wrong. If it's an error, it's probably a negative sign. So I'm going to go check my negatives. I went and checked my negative signs, guys. Most times you have an error, it's a negative error. So I made sure I had my negative signs in the right place and my minus signs in the right place.
-5 from the beginning one.
So, okay. And I get this, the square root of 89 minus 5 over 4. Now, again, I can get this answer for the one for the minuses by arrowing up, entering on that selection, and then going and just pressing left arrow until I get to the plus sign and turning it into a minus sign. A minus sign, not a negative sign. And dear goodness, it gives me negative square root of 89 minus 5 all over 4. And let's go back and look at our answers because they look a little different, but they are equivalent to this one. So you can take a look here. They have their negative 5 first, and we had our negative 5 behind, but we can see that we have negative 5 with a positive or negative square root of 89 all over 4. A is the right answer. Well, you know, I actually prefer to simplify those by hand because I'm not intimidated by the order of operation. I think it's easier. Let me show you what I mean. Because you don't have to do as much work on problems like this. You just stop. So like, I'm not going to simplify negative 5. 5 squared is 25. And then I'm just going to multiply negative 4 times 2 times negative 8 is positive 64 all over 4. And it's just 2 steps to simplify it to this stage because 25 plus 64 is 89. And there's nothing else I can do, so you just stop. These answers are so ugly because some mathematician said, hey, I'm about to get crappy decimals. Mathematicians hate crappy decimals. We just stop before the crappy decimal, literally. We don't like ugly decimals, and so we call that simplified. So it's actually easier to do by hand. All right. Okay, well, I'm super excited that you guys joined me in class today. I so appreciate you doing hard things with me, and I'm so proud of you guys. You're all brilliant. Smarter than Adam Sandler in that movie for sure. Okay, I hope to see you guys next week. Next week, we are going to be looking at a review of all the slope and lines and points that happen on the GED. So that is a really popular topic. Next to algebra, that's the thing you're going to see the most. Well, it's a part of algebra, but it is the part of algebra you're going to see the most on the GED. They love it, love it, love it. All right, see you next week. I know you didn't watch this whole long video only not to remember these things on test day. If you really want to remember what you've learned, it's so important that you practice. And not only do you need to practice math, you need to practice the type of mixed up style algebra that we did together. It's one thing to have the teacher prompt you and tell you, oh, look at this, look at that. How do we know what to do here? It's a whole other thing to decide what to do on your own. So make sure you get plenty of practice on this, and we'll see you next time.